Welcome to Chapter 8, Section 5, Reactions of Acids and Bases. You're primarily going to just want to be able to recognize the different types of acid-base reactions that can occur. So we're going to go through and talk about how to predict products and those things, but you also just want to be able to recognize these reactions. So basically, a typical reaction of an acid and base includes the reaction of an acid with a metal, so that's what we're first going to go over, an acid with a base, and an acid with a carbonate or a bicarbonate ion. Okay, and so the first one that we're going to look at is acids and metals. So these metals include potassium, sodium, calcium, magnesium. So these are the typical metals that acids will react with. And basically the product, so what you want to look for if it's an acid and metal reaction, is the fact that you're going to have a metal as a reactant, you're going to have an acid as a reactant, and you're going to produce salt plus hydrogen gas. Okay, so salt plus H2. Okay, a salt is an ionic compound. I know we discussed this in Chapter 7, but just to reiterate the fact that a salt is an ionic compound, which means it's composed of a cation and an anion, so a metal and a non-metal, and it does not have H+, so a proton or a protonated hydrogen as the cation, or a hydroxide as the anion. Okay, so it's not composed of that. It's a metal and non-metal, not including H+ or OH-, hydroxide or the proton. Okay, so if we look here, we've got a balanced equation, so we can't forget how to balance equations. Okay, and so we've got, in order for us to balance our hydrogen, so we have hydrogen gas, we have two of these, so we have to have a 2 here. Okay, and so that's going to make us have to have 2 potassium as well as 2 potassium chloride salts that are produced. Okay, and so what happens basically is our hydrogen, so I'm going to, give me 1 second here, and get my pen. So basically our 2 hydrogens are replaced by 2 potassium. So we're replacing hydrogen with the metal. Okay. We have zinc as our metal in the second problem here. And in order to balance the reaction, we have 2, so HCl is once again our acid. We produce zinc chloride and hydrogen gas. We produce hydrogen gas, a salt. We see all of these similarities here. And so the hydrogen here, so we're going to replace our hydrogens with a zinc. So we replace the hydrogen with a metal. Okay, so I want you to work on writing, I'm already showing you this. So write a balanced equation for the reaction of magnesium metal with HCl. So that's our acid, metal and acid. We want to label the metal, the acid, and the salt. Okay, so you can pause if you'd like. So we're going to go on and show here. Now we got this. So we have magnesium plus HCl. So that would be kind of your plan to start this. And we know that we're going to form H2. Okay. And we also know that we're going to replace our hydrogen with our metal. So this is going to be replacing our hydrogen. So we get MgCl. However, we can't forget to balance. Okay, so remember that. So this kind of goes back to earlier in the semester. Magnesium is in group 2, and our chloride forms a -1 charge. And so for every 1 magnesium, we need 2 chlorine. So we get MgCl2. Okay, that makes our charges balance, and that's the way that the magnesium and chloride are going to bond, so that they have the adequate amount of electrons. Okay, and we also want to go ahead and place a 2 here, because we have 2 hydrogens on the product side. We need 2 hydrogens. So we're going to look and check, make sure everything's balanced. It looks like it is. We also have our second type of reaction with acids, and this is our second type. Acids with carbonates or hydrogen carbonates. So remember that carbonate, the polyatomic ion, so if you look at your chart, your polyatomic ion chart, it's CO3, okay, that's our component of the polyatomic ion, and we want to look at what happens when it reacts with an acid, when carbonates react with acids. Remember that your polyatomic ion chart is on page 138, so if you want to keep referring to that throughout really both of the chapters here. But your carbonate is CO3 2-, that's your polyatomic ion. These are actually similar reactions to what antacid tablets do, and we're going to talk a little bit more about that at the end. But basically you have an acid that reacts with a carbonate. So you just want to recognize, I'm not going to try to trick you here, but calcium carbonate is one of the most common carbonates, as well as bicarbonate. Okay, sodium bicarbonate is actually what it is called. And basically it reacts with the acid to produce CO2. Okay, so you're producing carbon dioxide, okay, plus a salt plus water. So that is what is typical for an acid and a carbonate. Okay, if you have a bicarbonate, it's the same situation here. We still produce carbon dioxide, salt, and water. So it's the same. Everything is balanced as well. And the only difference here, we had to place a 2 in our coefficient because we have 2 hydrogens. Okay, whereas we already have 2 hydrogens in our second equation. So we're already balanced with respect to our hydrogen. Okay, so if you want to pause, you can. We're going to write out the balance equations for the following reactions of a carbonate. So it's identified by this CO3 here, reacting with an acid. Okay, the magnesium is going to form a salt. So our metal and our non-metal portions are going to form a salt. Okay, we get MgBr2, so go back if you have to and look back at naming, but we have, for every 1 magnesium, we need 2 bromine because of the charges. Magnesium's in group 2, it has a positive 2 charge, and bromine a negative 1. So to balance those charges, we need 2 bromines for every 1. Okay, and then we're going to produce CO2 plus water. So basically our carbonate and our hydrogen, in a sense, almost decompose into CO2 plus water. Okay, so you don't really have to worry about the logistics there. You just want to be sure you have to recognize what your salt is, your ionic salt, and plus CO2 plus water. Okay, if we look at our next equation here, we've got HCl and bicarbonate. So it's kind of a trend here. We're not having to balance we don't have all of our coefficients are 1 to 1. So it's a 1 to 1 to 1 to 1 whenever we have this bicarbonate. Okay, up here we had to place a 2 in front of our HBr because we have 2 bromines here as well as 2 hydrogens. Okay, and so our salt is going to be the anion portion of our acid, combining with the metal of our carbonate to form NaCl plus CO2 plus water. So basically get this kind of a decarboxylation, kind of the term for that, but it kind of breaks down to CO2 plus water. The third reaction, probably the most common for acids and bases is a neutralization reaction where you add acid reacts with the base to produce salt plus water. So don't get this confused with the previous example where we produced CO2, salt, and water. Okay, here we're going to just be producing salt plus water, and we're doing exactly what the name of the reactions are called. We're neutralizing the acid and the base, and so we're left with, when we do this in the lab, if we take an acid and we add adequate amount of acid to our base, we actually just neutralize it, and so it becomes salt plus water. Okay, the salt formed is the anion from the acid. Okay, so it's the anion from the acid, and the cation of the base. That's what's composed of your salt. And then what you're left with is two hydrogens and an oxygen, which forms water. Okay. In a neutralization reaction, if we write the strong acid and strong bases as ions, we see that the H+, our protonated hydrogen or hydrogen ion, reacts with hydroxide to form water. And this leaves the ions the sodium ion and the chloride ion in solution. So basically this is just looking at an ionic equation. So if we look at what we had previously, where we had HCl plus NaOH, gave us water. We can actually see how the water is produced. And how we do this is we basically just pull apart, since we have strong acid and a strong base, we just kind of pull them into their constituent ions, once again, like we're ionizing each of them. So our HCl will ionize the hydrogen and chloride. Okay, we get an H+, and then the Cl- because chlorine is in group 7. Sodium is in group 1, so we get a +1 charge, and hydroxide is on our polyatomic ion list, but by now you probably know it has a -1 charge. Okay, our salt is also going to ionize, so it will become Na+, and +1, and sodium here, and then we get water. So water does not ionize. And so basically from this, I'm not going to have you to derive this. This is basically called a net ionic equation. And so the net ionic equation comes to this. Because basically if we look at each side of the equation, we have common ions. So we can cancel out the chloride. Anything that's like terms, cancel out our sodium ion. And now we're left with H+ plus OH- hydroxide gives us water. And so basically the overall reaction, the net ionic reaction from the acid and the base, form water. Okay, so this is how we get our water. So we saw how we get our salt, and this is also showing you how you would get the water. Okay, you can also think of this in the Bronsted-Lowry acid-base theory. Okay, so you can also look at it that way. So we have HCl, NaOH. Our acid donates a proton, so we get this, and we get and then we can combine our positive and negative charge to make our salt. But basically, the main thing you want to see from here is that this is how the water is formed. When we break down the net equation, we get H+ plus hydroxide gives us water.